Okay, let's get started here with number 1. G of x times h of x times k of x minus f of x. So we just need to make those simple substitutions. Here's g of x. Here's h of x. Here's k of x. And we're going to subtract f of x. Okay, so if we multiply these two together, get the result, multiply that times that guy there, and then subtract f of x. Multiplication before subtraction, right? Or keep in mind this is not multiplied by this at all, it's subtracted from it, okay? Or I can multiply these together first, or I can multiply this first one by this third one, any way I want to go. But first I'll multiply the 3x times the 4x, and get 12x squared. 3x times negative 7, negative 21x, 5 times 4. We get a positive 20x, 5 times negative 7, minus 35. And I'll just go ahead and combine like terms, 12x squared minus x minus 35. Alright, then we'll just bring everything down here. 5x plus 2, minus 2x squared minus 8x plus 1. Alright, we multiply this out again, so 12x squared times 5 is 60x cubed. 12x squared times 2 is plus 24x squared. So distribute the 12x squared, move on to negative x. So we get negative x times 5 is negative 5x squared. Negative x times positive 2 is negative 2x. Move on to the negative 35. We get negative, I don't know off the top of my head what this is, but 35 times 5, negative 175x plus 70, negative 35 times 2, sorry, not plus, minus 70. Okay, and now we'll just go ahead and combine like terms here. 60x cubed plus 19x squared minus 177x minus 70, just combining like terms. Okay. I'm going to bring this down, but at the same time I'm going to distribute the negative, so I'll have a minus 2x squared plus 8x minus 1. And we just combine like terms, so final answer is 60x cubed. 19x squared minus 2x squared is 17x squared. Negative 177x plus 8x is negative 169x. Yeah, that's right. And then negative 70 minus 1 is negative 71. There it is. We're going to factor this as 3x to the 4th plus x squared minus 14. And I said hint, it's in quadratic form. If I gave you 3x squared plus x minus 14, or maybe I shouldn't use x, I should use something else like p. 3p squared plus p minus 14. Okay, how would I factor this? I could try it brute force, where I know that I'd have to have a 3p in front here and a p there in that binomial, and just kind of work it out. Like I need two numbers that multiply to negative 7 or negative 14 that add. Once I multiply one of them by 3, add up to positive 1. Let's see, I'm going to try 7 and 2, so how about negative 7 here, 2 here. I just imagined multiplying this out in my head, and I saw that 3p times 2 is 6p. Oh, I went the wrong way. I should have done a positive 7 and a negative 2. That works. Okay. If I multiply this out, I get 3p squared. I get 7p minus 6p, that's p, 1p. 7 times negative 2 is negative 14. This is just like that. It's in quadratic form. It's not a quadratic exactly. Quadratic is specifically the highest power is 2. But it factors just like a quadratic. If I replace a p with an x squared, I get 3x squared plus 7 times x squared minus 2. I guess I should have written that right there, because that is the answer. And X-intercept is indicated on the graph. Find and graph the remaining X-intercepts, sketch the graph. You might want to find some other points. That's good advice. So since negative 1 is an X-intercept, that tells me that f of negative 1 equals 0, right? Negative 1, 0 is a point on the graph, so it tells me that if x is negative 1, then y will be 0. So I know from this that x plus 1 is a factor. Okay, so I can factor that out of here. I can do long division. I can do what I like to call common sense style. You can do synthetic. I am going to go ahead and do what I call common sense style. How about that? X plus 1 times something is going to give me this polynomial. I have to figure out what that something is, knowing that x times this to start with is going to give me 2x cubed. So this would have to be 2x squared. X times 2x squared is 2x cubed. 2x squared times 1 is 2x squared. But how many x squareds do I want? I want negative 7x squared. So I need to subtract 9x squared. All right, that's what needs to come next as I'm multiplying each term and distributing each term into x plus 1. So that would have to be a negative 9x. Negative 9x times x is negative 9x squared. Negative 9x times 1 is negative 9x. But I want negative 14x. So I need a negative 5x. So that means I need a negative 5 here. And negative 5 times x is negative 5x. Negative 5 times 1 is negative 5, exactly as I wanted it to be. Right? I'm figuring out what this polynomial has to be so that when I multiply it out, I get this polynomial here. Now, this is just my check. I'm just going to go ahead and erase it to make room. Now I have this quadratic that I can factor, use a quadratic formula to solve. Right? I'm trying to figure out the x-intercept, so I'm trying to figure out what values of x will give me 0 as my y value. So x plus 1. Here, let's factor this a different way. I guess, like in the previous problem, I just figured it out. We could figure this out pretty easily too, but let's do factor by grouping. Let's do factor by grouping. So 2 times negative 5 is negative 10. Two numbers that multiply to negative 10 and add to negative 9. How about negative 10 and 1? So we rewrite negative 9x as negative 10x plus 1x. And here's a minus 5. Factor by grouping now. Group and group. This group has a 2x in common, so we get x minus 5. This has a 1, if you like. It makes it easier to see how it's going to factor. X plus 1 times, we factor out the x minus 5 factor, times 2x plus 1. That all equals 0. So we have an x-intercept of negative 1. We do that. 5, we just figured that out. And if I set this equal to 0 and solve for x, I get negative 1/2. So I have 1, 2, 3, 4, 5. I have a x-intercept at 5 and x-intercept at negative 1/2. Okay, so these two are very close together, and we'll either see like a little bump above here or a little dip down here. Let's see, it's a degree 3. It's a positive leading coefficient, and the end behavior should look like this. Okay, and from our work, we have the advantage of knowing that there's no repeated factors, so there's no bouncing off of any of these x-intercepts. They just go right through each of these x-intercepts. So how about we just go like this? Okay, is that exactly right? No, it's never going to be exactly right. In fact, let's look at what this part should really look like. Let's plug in 3 for x. Okay, let's plug in 3 for x. That's 2 times 3 cubed minus 7 times 3 squared minus 14 times 3 minus 5. That's going to be pretty negative, right? We have 27 times 2, that's 54. This is 9 times 7, so that's negative 63. 14 times 3 is negative, let's see, 42? 42. Yes, and minus 5. So 54 minus, I'm not going to try and do this subtraction in my head. 54 minus 63 minus 42 minus 5 is negative 56. So this should really go down to negative 56, which I don't have room for. This graph is fine if you say you did that, right? And you found that it should be at negative 54, then this graph is great. You know, it just kind of stops there. It goes down there. And, you know, just kind of indicate that I just don't have room to go all the way down to negative 54. So that one's fine too. Just goes off the screen, if you will. If this were like the screen of your graphing calculator or something. Well, I should leave the instructions on there. Given the polynomial function f and 0, find other zeros. So if negative 2 is a 0, then x plus 2 is a factor. Let's do synthetic division. Negative 2 goes out here, right? If I want to find if I want to plug negative 2 in here using synthetic division, I would use negative 2 here. If I want to test and see if x plus 2 is a factor, I would use negative 2 here. It's all the same. So we had 6, negative 1, negative 31, negative 10. No need for zeros anywhere in there. All of the x powers are represented. Bring down the 6, negative 12, negative 13. Make sure I'm doing this right. And then negative 2 times negative 13 is 26. And then 26 minus 31 is negative 5. That gives us a positive 10 and a 0. So we have 6x squared minus 13x minus 5. Right? If I multiply that by x plus 2, that'll give me the original polynomial. Let's see, I'm trying to find the other 0. So I'm going to factor this guy, right? Have it set equal to 0. How will it factor? How about 6 times negative 5 is negative 30. Two numbers that add to negative 13 and multiply to negative 30 would be negative 15 and 2. Yeah, negative 15 and 2. So 6x squared minus, what would be easiest? Maybe do, it doesn't matter, 15x. I could do minus 15x, or I could do plus 2x. Doesn't matter the order that I write these. Oh, maybe I should have, whatever. We're just going to keep going here. X plus 2 times this group has a 3x in common, so that leaves us with 2x minus 5. This group has a 1 in common, that leaves us with 2x minus 5 there. So we have x plus 2 times, factor out this 2x minus 5. We're left with 3x plus 1. Set this equal to 0, you get x is negative 2. We knew that already. Set this equal to 0 and solve for x, you get 5 halves. Set this equal to 0 and solve for x, you get negative 1/3. Alright. Alright, I kind of paused the video there. I was afraid I wasn't recording sound, but I was, so here we go. We keep going. Factor the polynomial completely. Okay, so is there anything in common that they all have that I could factor out? Almost 2, but this doesn't have a 2, and this doesn't have an x. Nothing can be factored out that they all have in common. What about factor by grouping? There's 4 terms. Maybe it's just kind of this old idea of factor by grouping. This group has an x squared. That would leave us with 3x plus 2. This group has a negative 4 in common. Factor negative 4 out, you're going to get 3x. Factor negative 4 out, you're going to get a positive 2. That works. So we have 3x plus 2 times x squared minus 4. But x squared minus 4 is a difference of squares. So I can factor this as 3x plus 2. That stays the same. And this would be x plus 2 times x minus 2. Find all the zeros from scratch. So can't factor by grouping because there's 5 terms, not 4. We're kind of stuck. We're just going to have to do the rational zero theorem. So we'll list all the possible zeros. That's going to be the factors of 6. That's 1, 2, 3, and 6. And I would take it over the next factor of the leading coefficient, but the leading coefficient is 1, so real easy for us. 1, 2, 3, and 6, positive and negative. So here's what I would be doing. I would just put 1. Just start with 1. Put my coefficients here, 1, 3, negative 11, negative 6, 4, 3, 2, 1. Okay. Making sure I got all the powers of x in there. No zeros needed. Okay, bring down a 1. 1 times 1, that's 4, 4, 1, 1, and negative 10. That's not going to work because that's not going to give me a 0 here at the end. So back it up. Sometimes these little guys disappear when I do that, so just have to watch out. So a positive 1 did not work. Let's try negative 1. Bring down a 1, negative 1, 2, negative 5, 5, negative 6, 6, and 0. Great. So now I have, all right, let's see, I'll write off to the side. I know that x plus 1 times x cubed plus 2x squared minus 5x minus 6 would give me the original polynomial. Now I have this third degree. I don't know any of its zeros, so I'm going to have to do the rational zero theorem again. My constant and my leading coefficient are the same, so the list is the same. The thing that I know now is that positive 1's not going to work. So let's try negative 1 again, because that could happen. Put a 1 there. Negative 1 times 1 is negative 1. 1. Negative 1 times 1 is negative 1. Negative 6, positive 6, 0. So now I know x plus 1 times x plus 1 times, oh, that's a 1, and that's a parentheses, times x squared plus x minus 6 would give me the original polynomial. Now I just need to factor this quadratic, which is a super simple quadratic. Goes back to the first days of factoring quadratics. All right, two numbers that multiply to negative 6 and add to 1, so 3 and negative 2. So I know my zeros are negative 1, another negative 1, a negative 3, and a positive 2. All right, by setting each of these factors equal to 0 and solving for x. Okay, we're going to find all the zeros as a polynomial. It's a third degree. It's kind of like this situation here. It's a third degree. I don't know any of the zeros. None of them are given. And you know, I can't factor by grouping. I wonder if I could have factored this guy by grouping. No, this wasn't factorable by grouping, so never mind that. There's nothing in common among all these terms, so we're just going to have to do the rational zero theorem. Plus or minus 1, plus or minus 2, plus or minus 4. Alright, and here we go. Let's try 1. Put a 1, make sure to put a 0 there for these 0x squareds that you want. And negative 4, bring down the 1, here we go. Let's see, 1, 1, 1, negative 1, that didn't work. Okay, so let's get rid of all that. So, no, 1, no worky. Negative 1, 1, negative 1, negative 1, 1, negative 1. No, that didn't work either. So let's erase all this, erase all this. And now I know that negative 1 doesn't work. Let's try 2. 1, 2, 2, 4, 2, 4, 0. All right, cool. So now I know that x minus 2 times x squared plus 2x plus 2 gives me the original polynomial. I'm looking for the zeros, so I'll set it equal to 0. I just need to factor this guy, but I can't factor x squared plus 2x plus 2. It's unfactorable, so I'll use the quadratic formula. Right, so negative b plus or minus the square root of b squared is 4 minus 4 times a times c over 2 times a. That's negative 2 plus or minus the square root of 4 minus 8. That's negative 4. So that is negative 2 plus or minus I times the square root of 4. Square root of 4 is 2, so we have plus or minus 2I. Now the numerator can have a 2 factored out, right? Each of these terms has a 2 in common. I could factor that out. Cancel it with this 2. So I'm left with negative 1 plus or minus 1 times I. So I found 2 is a 0. Negative 1 plus or minus 2i. Those are the other two zeros. Okay. Now, I have these zeros. What do I do with these zeros? X plus 2 is a factor if negative 2 is a 0. X minus 1 is a factor if positive 1 is a 0. X minus 2 is a factor if 2 is a 0. The thing that I notice here is x plus 2 times x minus 2 is easy to multiply. That's conjugates, right? They're going to multiply out to a difference of squares. It's going to be x squared minus 4. And I'll multiply that by x minus 1. If you multiply these together, you know, it should work out just fine. It should work out exactly the same. Then we get x cubed minus x squared minus 4x plus 4. And I guess I should write that down there because that's what it is. I should really call it f of x or y equals or something because it wouldn't be a function really otherwise. I wasn't too picky about that though. All right, if 2 minus 3i is a 0, then 2 plus 3i is a 0 by the rational.
Sarah was wondering if you want scrap.
All right, sorry about that, getting some copies. Rational, no, not the rational, it is the complex conjugate theorem. So by the complex conjugate theorem, if 2 minus 3i is a 0, 2 plus 3i is a 0. So, let's take this nice and slow here. First, let's say x minus 4 is a factor. Okay, we know that. And remember that anytime I know a 0, I can just throw it x minus the 0, and that makes a factor. Okay, just like x minus 4 made a factor. So x minus 2 minus 3i, and another factor would be x minus 2 plus 3i. Let's distribute those negatives. X minus 4, x minus 2 plus 3i, x minus 2 minus 3i. I'm going to group these like this. If you didn't group them and you just multiplied it all out, everything will work out just peachy. It'll be fine. Maybe a couple extra steps, maybe some room for errors because there's so much going on, but it will work out exactly the same as long as you don't make any mistakes. But if we group x minus 2 as a little bundle and x minus 2 as another little bundle, then we can take x minus 2 and distribute it to x minus 2, make that part easy on ourselves, get x minus 2 squared. The thing you need to remember right here is that when I multiply this by this, it will be like one thing, right? The whole thing. And the result of all of that whole thing, all of it will have to get multiplied by x minus 4. All right, continuing on. X minus 2 times negative 3i will be negative 3i times x minus 2. You could distribute that 3i, but it's going to get canceled out really fast here in the next few seconds. We're done distributing the x minus 2 bundle, and now we'll distribute the 3i. That gives us a 3i times x minus 2. Like I said, negative 3i times x minus 2, positive 3i times x minus 2. We add a positive and a negative. They're going to cancel each other out. 3i times negative 3i is going to be negative 9i squared. Let's bring this up here. Now we have x minus 4 times, I'm going to multiply this out. That's going to be x squared minus 4x plus 4. If that was too fast, just take a second, pause the video. X minus 2 times x minus 2. You'll get this guy here after you combine like terms. Then I squared, remember I squared is negative 1. Remember, let's write it over here. I equals the square root of negative 1. I squared equals the square root of negative 1. Squared, square and square root cancel each other out, and it's negative 1. So negative 1 times negative 9 is positive 9. So that, like I was saying, that whole group there is inside this parentheses. All of it we need to get multiplied by x minus 4. So we have x minus 4 times x squared minus 4x plus 13, just combining like terms. Here we go. X times x squared. Just going to go the other way. X squared times x, x to the third. X squared times negative 4x squared. Now the negative 4x times x is negative 4x squared. Negative 4x times negative 4 is positive 16x. 13 times x is 13x. 13 times negative 4 is negative 52. And we'll combine like terms, that'll be it. X cubed minus 8x squared plus, let's see, 29x minus 52. And we could say f of x equals, and we'd have ourselves a polynomial function, input and output. Can't get output without the other side of the equal sign. Alright, we're going to graph these polynomials. Let's get some x-intercepts, some more points, check our end behavior. First off, it's a third degree with a positive leading coefficient. I know it's going to be like that. Okay, so we need to find the x-intercepts. Factor by grouping, I can quickly see doesn't work. I'm going to find the x-intercepts with the rational zero theorem, finding zeros. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Alright, so I'm going to start with 1. Alright, we have 1, negative 2, negative 5, and 6. 1, and here we go. 1, negative 1, negative 1, negative 6, negative 6, 0, lucky. X minus 1 is a factor because 1 is a 0, and that multiplies by x squared minus x minus 6. This is similar to one we just did a minute ago. That's fine. X minus 1 times x minus 3 times x plus 2 equals 0. So we have x-intercepts at 1, at positive 3, and at negative 2. Okay? I know I know that this graph should look something like this. There's no repeated zeros, so there's no bouncing off of these x-intercepts. It should look something like that, and that's fine. But further investigation, like if I plug in a 0 for the x, I'll find a 6 for y. So 3, 4, 5, 6. Actually, my graph should go up through here if I wanted to make it look better. Alright. So it should look something more like that. Maybe I plug in 2. If I plug in 2, I'm going to get 8 minus 8 minus 10 plus 6, so negative 4. 3, 4. So then my graph should look something more like this instead of what I had before. That would be good. Now it looks pretty nice. If you were to plug in something bigger than 3, like 4, 5, or 6, whatever, you'll find that you just get these bigger and bigger numbers confirming the end behavior. So this looks good. If it were like this, I might try to make this a little less cornery, a little less jagged, a little more smooth. So there you go. That's pretty nice. Let's see. I thought I had something else to say about it, but this is all. Oh, circle any relative extrema. Here is a relative maximum. Here is a relative minimum. Because in this relative area, I just kind of concentrate on where I've circled here. There is the maximum value. I didn't ask you to say what it was. Some of you guessed, and that was great. But you don't know for sure. This guy down here, this is the y value at this point is the relative minimum. So that was all I was asking for there. This is pretty simple. It's all factored, so I know that if I set each of these equal to 0, I would find negative 3 is an x-intercept, negative 1 is an x-intercept, 1 is an x-intercept. This repeated factor, it's got an even power there, so I know it would bounce off. Okay. I know if I multiplied it out, it'd be a 4th degree with a positive leading coefficient. If you don't believe me, multiply it out. You got quadratic here because it's a linear factor times itself. That's going to be a 2nd power. Multiply this by that guy, you'll have a 3rd degree. Multiply that 3rd degree by this guy here, you'll get a 4th degree. It'll be a positive leading coefficient. So I know the end behavior is up to the left and up to the right. And I know it's going to bounce off of this. It's going to go through this x-intercept, and this x-intercept is going to go through that too. So this would be okay. All right. I can plug in things like negative 2, figure out what I get for my y value. Plug in 0, figure out what that gives me for my y value. Turns out you get the same thing. I think it's negative 3. Last thing, though, is to circle any relative extrema. Here is a relative minimum, and a relative maximum. And that is it. And that's the whole thing, I think. That's all the questions. That's it. So thank you for watching. I hope that was helpful. Let me know if you have any questions.